Jai Hind everyone. I am Khushbu Malviya, Assistant Professor in AKGEC. Today I want to describe some introduction on data structure. So I discuss today some basic about data structure. So we move on, next slide. So this is my outline of my presentation. What is data structure? Why is data structure is used? Classification of data structure, operation on data structure, and ADT, abstract data type. So before understanding what is data structure, firstly we have to know about what is data. So what is data? It can be defined as a value or set of value. So name of any person, like your name, if your name is Rahul, this is data. My name, Khushbu, this is data. ID of an employee, this is data. If I take an example of a student, so roll number of a student is data. Email ID of a student is data. Contact number of a student is data. So everything is data. Today in the world we generate data day by day. So we know how to data is structure. Okay. So what is the data? Anything. Audio, video, name of person, ID of employee, salary, etc. All is data. So see in this diagram, when you enter in a data, so here is data, we give input, okay, and after processing we get information, output. So in what will happen in memory part what produce, okay, when you give input in a data, so if you want to storing a data, updation of data, optimize data, so where you perform on memory, okay. So all data you are process in memory. So this is the basic structure of how data is entered and where is processed and how you get information. So in a memory, role of a data structure is start. So I describe what is the role of data structure. Suppose you want to store 10 elements. So what you do? So you write integer, okay, A1, A2, A3 up to A10. But if you know about a data structure which is array, so you only write one variable, that is A10. And what is data type? Is integer. Okay. So by integer array, you store 10 elements. Instead of you write 10 times a variable A1, A2, A3 up to A10. So if you have a knowledge of how data is stored and how it give efficient output to us, so here come role of the data structure. The next, if you want to search an element in a search an element, so there are two ways for search an element. Okay, two types of searching is used, linear search and binary search. So in linear search, what happened? In linear search, if you have an array and you store 5 elements, okay, so you search one by one, 1, 2, 3, 4, 5, okay, one by one you search. So it take more time. Instead of, if you use binary data structure, so number of comparison is less, because the binary structure principle is, here we take an example, root node. If you have a 10, so less than value of 10 placed in right side of the data structure and greater than value of root node placed in right side data structure. Here left side of data structure, here less than value left side and greater than value right side. So if you want to search a value 5, so what you do? You search, you see what is root node, and after that you see less than value is 5. So number of comparison is less compared to in linear search, because linear search is started from the 0 index, okay, 0 index. You know about what is the role of the data structure. So you get processing fast, you get information fast in timely manner. So it is a data. Data is the name of person, ID, employee, salary, etc. So I describe you role of the data structure. We move on next slide. So what is the data structure? It is a way of organizing or storing data into the memory. See here, organizing and storing the data into the memory. Firstly, if your data is organized, then your efficiency, your outcome is processed fastly. You take output very fast. Okay. So organizing data in a proper way is called data structure. Okay. And if your data is organized, so what you do? You perform so many operation on that. So operation like insertion on array, deletion on array, okay, traversing on array, searching, merging. So you perform operation on data. So you get information efficiently. Okay. So there are many example of data structure: array, stack, queue, tree, graph, etc. We discuss one by one. So here question is arise, why, what the need of data structure? Why we use data structure? Okay. So I describe you firstly by real example, and that we discuss about programming point of view. Okay. So organizing data has major impact on performance. How? Suppose we take an example, queue at a ticket counter. If at ticket counter a queue is maintained, okay, a queue is maintained. So the first person who want to ticket, he gets service first, and second one want to take ticket, he service second. If queue is maintained, then there is no problem. Okay. But if queue is not maintained, okay, then what happened? A person which come last take ticket first, and who waiting first, maybe he not take ticket. So this is very necessary to very necessary to maintain a data structure. So here ticket counter, queue at a ticket counter. So number of person, this is data. This is data. Number of person, this is in our example data, and it follow a queue. Queue is a data structure. So queue is also one type of data structure. So here I give example of queue data structure. Second example is dictionary. So if you want to search any letter, any word, like you want to search height, okay, so if your dictionary is, what happen in dictionary? Dictionary is arranged alphabetically. Okay. So if you want to search height word, you move on which section? Height, at section, and you get easily this word. If your dictionary is not arranged, then what will happen? You not get height word in a timely manner. Okay. You search and move page and page, and you not get. So it is very necessary your data is in one type of structure, follow one type of structure. Now second example is queue in a printer. What happen in a printer? You give, when you give command, print command, you give job on a CPU, then first job is performed, after that second job is performed, after that third job is performed, and so on. So queue is queue in a printer. So printer is based on queue data structure. Okay. Next, arrangement of book in a library. Arrangement of a book in a library. You see in a library, all section is divided. Library, in one section computer science book is arranged, one section data structure, one section physics books arranged. If this books is not arranged proper in section and you search any book, so can you get these books easily? No. Why? Because arrangement is very necessary. If anything is not arranged, you not get in a proper time. So this is the real life example where we need data structure. Data is arranged properly. So book here is our data. And what is the structure? Your cells, all cells, which is you divide section, like here physics, here maths, either computer and science books, and like that. Okay. So now we move on next slide. And now we know at programming point of view, what is the data structure? Where is it? So therefore choosing an appropriate data structure improve the performance of a program or software. Okay, if you are a programmer and you create a software, okay, you create a program. So what you want your program is give output in timely manner, okay, in an efficient manner. In efficient manner both way, like timely, and storage your program is less. Okay, so when you write any program, so you firstly write one algorithm, and if you know I write this algorithm and which data structure is I use, can I use array, can I use queue, so my program is give efficient output in a timely manner. So you have to knowledge about data structure. So algorithm and which type of data structure is you use, okay, is combined and making program. So according to point of view, you have to knowledge about data structure, which type of data structure. In previous slide I give example, if you want to store a data of 10 element, so you define an array instead of you define variable a1, a2, a3 up to a10. So you have knowledge about data structure and you write an algorithm. And these, if you use array, then your program give output efficiently and timely. Now we move on the next slide, classification of data structure. So here we know about what is a data structure. So data structure is classified in two terms, primary data structure and non-primary data structure. Okay, primary data structure is also classified in integer, float, character, pointer. Non-primitive data structure is also classified array, list, files. Now list is also classified two types, linear list, non-linear list. Linear list, a data structure which is linear, which is arranged one by one. So example of linear data structure is stack and queue. But if your data, your values is not arranged linearly one by one, means this type is your data is not arranged one by one. So your data is arranged like this, in this way. So you use graph and tree. Okay, I describe this primitive data structure, non-primitive data structure one by one. So what is a primary data structure? Primary data structure is built-in type data structure. It is predefined. Okay, no changes. User cannot do any changes. Okay, this is predefined. Okay, means you not change size of the integer. Size of the integer is defined. Size of the integer is 4 byte in new compiler, and size of integer is 2 byte in old compiler. You not change. You cannot change this value. Okay, it is predefined data structure. It is also machine dependent. So here is very important term, machine dependent. What is machine dependent? If you use 16-bit machine, so data of integer is 2 byte. Data is 2 byte and you cannot change. If you want 6 byte, no, it is not changed. Okay, it is machine dependent. It is predefined. If you taking 32-bit processor, 64-bit processor, so it is 4 byte. Okay, if you want character data type, so character data type is taking 1 byte. Okay, so primitive data structure, in previous slide, primitive data structure is what? Like integer, float, character, pointer, double, long, short, all is primitive data structure which is predefined it and machine dependent. Okay, size is fixed. What is non-primitive data structure? Non-primitive data structure is user defined structure. If you want to store 10 element, so you declare array of 10. What you declare? Array of 10 elements. So it is user defined. Here you give size of the array. How many element you want to store? User give. Okay, user give 10 element. I want to store 10 element. So size of the array is fixed by you. So it is user defined array. Number of data structure which is user defined. If you want to define a stack, so stack is user defined. Tree is user defined. Graph is user defined data structure. Here size is measured by you. You give size. Okay. Also called derived data types. Non-primitive data structure is also derived. Also called derived data structure. Why it is called derived data structure? Because you declare array of 10. But if you give data type of array, which type of element you want to store? You want to store integer type of value. Here I write 10. You want to store numbers 1, 2, 3, 4, 5, 10. Okay. So number is data type integer. So integer is what? I said before, integer is primitive data structure. How many data structure is primitive? Integer, float, character, and so on. Okay. So here you take integer. So integer is what? Integer is primitive data structure. And array is what? Array is non-primitive data structure. It is user defined data structure. So what we say here, non-primitive data structure is derived data structure. So it is derived from what? We take integer. So it is derived from primitive data structure. Okay. So in our first slides, here is non-primitive data structure like array, list, files, and it is also classified in linear list and non-linear list. So now I describe linear list and non-linear list. So what is linear data structure? Data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent element is called linear data structure. Okay. If your data is arranged linearly, okay, like one type of array, okay, array index is start from what? Where? 0. So if you arrange linearly, so your data is linear structure. Okay, like array, linear data structure, queue, linear data structure, linked list, linear data structure, where all data are arranged sequentially and element are attached by previous and next element. Okay, so this is linear. What is non-linear data structure? Just opposite of linear data structure. If your data is not arranged linearly, so you call this is non-linear data structure. Okay, so non-linear data example is tree, graph. In a tree, how data is arranged? In a tree, data is arranged. First is root node, then left child, then right child, and again left and right. In this way, data is stored. So it is linear? No, it is not linear. How in a graph? Example of non-linear data structure is graph. So in a graph, data is arranged how? In a graph, data is arranged like this and by joining edges like this, and like this. So data is arranged this type of. So this is not linear. And this is stored memory. And this is stored in memory not linearly. So this is a non-linear data structure. We move on, next slides. So here one term is come, what is static data structure and what is dynamic data structure. So before compiling any program, if you give size previously, okay, so this is one type of static data structure. The static data structure has fixed memory size. It is easier to access the element in static data structure. Like I take an example of array. When you declare an array, when you initialize an array, first you give size of array. After that you store element in array and you compile and you run. So before running any program, if you give size, then this type of data structure is called static data structure. Size is fixed. If you declare any array of size 10 and you store only 8 values, okay, and two memory are not utilized, then you declare 8 and you not change the size of the array because data structure is static. Okay, so in linked, so this problem is here memory is not used, so this problem is replaced by another data structure which is called linked list. In linked list we giving size on after running, after compile time. Okay, so what is a dynamic data structure? In a dynamic data structure, the size is not fixed. You give size according to your choice. Okay, at runtime, it can be randomly updated during the runtime, which may be considered efficient concerning the memory space complexity of this code. Okay, I give you one example of dynamic data structure. Like you use IRCT IRCT app. So when you travel any city to city, any state to state, so you see updation of where is train, where which route is follow, where is waiting, where is train is running. So all this happen by a dynamically data structure. Okay, you give size of the data structure, you perform any updation on data structure dynamically. You not give predefined size of the data. So this is a static data structure and dynamic data structure. Now we move on next slides. Operation on data structure. You arrange all data and you follow a data structure. Okay, so how many types of operation is performed on data structure? If you taking array, so which type of operation is performed in array? So first is insertion. Okay, insertion. Suppose you take an array of size 5. Okay, of size 5. So you insert an element. If you insert an element in array, so this type of operation is called insertion. You can insert an element from first position. You can insert an element from first position. You can insert an element from last position, and you also insert an element from any specified location. Okay, if you want to insert an element here, you can. If you want to insert in that position and here one element is present, so don't worry, you can insert in this position. Okay, you shift this element to here and insert an element is here. Okay, next element. So insertion in array, you can insert from first position, you can insert from last position, and any specified location you can insert. So next operation is deletion. Same insertion, like you want to delete any element from your data structure, you can delete from first position, you can delete from last position, and you can delete from any position. Okay, the next operation is traversing. So what is a traversing? Visit the element at least once to perform some specific operation like find sum, average, count, note, enlist, etc. are traversing. So if you want to find sum of 10 element, so what you do, there is two way. First way is you define A1 to A10 element. Okay, second way is you define an array. and taking a loop, I is 0, I less than 10, I plus plus. Okay, and you traverse our element and find the sum of element. Traversing means at least once you can visit all element. This is called traversing. The next operation is searching. So what you perform on searching? If you want to search any element in a list, so you perform searching operation. To find whether an element is present or not the given data structure, you perform searching. There are two types of searching: linear search, binary search. This is all our data structure types, operation of data structure. Now second is sorting. What is sorting? It is a method to arrange the element in a particular order, either in ascending or descending. It's called sorting. If you take in an element like this, so here data is not arranged, not sorted. 6, 10, 3, 2, 1. If you want to sort the data, you perform many types of sorting: insertion sort, selection sort, bubble sort, and you arrange this data in this way. 1, 2, 3, 6, 10. So this is arranged in proper manner. We sort data in ascending order. Okay. Second is merging. Merging operation. In merging operation, it is method which takes two sorted lists of similar data type as an input and produce combined stored list as output. In a merging, if you're taking two array, one array and two array, and you want to combine, if you want combine, then this is make one array. It's called merging. Suppose I take 6, 10, 3, 2, 1, and next one is I arrange this. This is one array and I arrange second array. If you want to merge both this array, then I make one array, which is 1, 2, 3, 6, 10, 11, 12 and 13. So I merge this two array in single array. So this type of operation is called what? Merging. Now we move on. Next slides. What is abstract data type? Okay. Abstract data type, we know about one example. We will see one example. To start the TV in your home, what you do? You simply press on button without knowing its implementation detail. If you want to change channel, so what you do? You only press a button and your channel is changed. Okay. If you want to turn off TV, what happened? You only click a button. Do you know in remote? No. So what is abstraction? Abstraction is focus only what rather than how. Okay. You only want to you only want to know what you want to do. You want to do you want to start TV. So you simply click. You don't know about implementation part. So this is called abstraction. You focus on what, not you focus on how. How your implementation is done. You not focus on that. Okay. So what is abstraction? Abstraction is only present only the simple view of any object but hide the implementation detail. Implementation detail. Hide implementation detail. So this is called abstraction. Next is, so now we move on our technical term. What is abstract data type? So abstract data type is representation of the logical or mathematical model for any data structure. It is basically describe representation of data. How you represent data? You represent data in integer. You want to take array. You perform any operation like insertion, deletion. How it is performed? I take one example of data structure in next slide. How it is performed? This based on how it is, what the implementation is done, it is not knowing about anyone. So our next slide is stack. Stack is one type of ADT. Stack abstract data type. Stack is follow which rule? It is follow LIFO, least in and first out. Okay. So what happened in stack? if you enter element, any element first, so it take out lastly. This element is you enter last, so this element is take out lastly. So it is based on LIFO, last in first out. So this stack is, I said, one type of a data structure. So for insertion, for deletion, for checking stack is empty or not, there are many operations performed like push operation, pop operation, pick operation and empty operation. So what is in push operation? What happen in push operation? Insert an element at the top. If you want to insert an element, then you perform push operation and you declare in a program push. So this is known by a compiler that you want to enter element in array. So push is what? Push is one type of abstract data type. You don't know how push is performed, how push is working. Only you declare push operation in your program. Push operation. So compiler is no, yeah, push operation. User want to enter element in a stack. Okay. Second operation is pop. Pop operation what perform? Pop operation remove an element. Okay. So if you declare in your program pop, so your all element are deleted. So this is what type of operation? This is ADT, abstract data type. Okay. Thank you.